Okay, so if you look at your first question, now after the review exercise, I think you should be capable of telling what is the horizontal asymptote straight away. What's the horizontal asymptote here? Y equals to 7. Okay, and the reason why it's 7 is because the degrees are the same. Okay, they both have x squared, so you just look at the ratio. It's 7/1, so y equals to 7. Now, it's also very important that you have this instinct, your sensitivity to factor. If not, a lot of information will be kind of difficult to find out. So for the numerator, you will factor this one. Okay, you will take out the 7x since they both got 7 and x, okay, inside. And then for the denominator, you will have x minus 4 and x plus 3. Now, at this moment, I would say it's still a good practice to write down or think about the restrictions. So x cannot be what in this case? After factoring, we look at the denominator, we say x cannot be 4, and x cannot be -3, okay? Now, so once we now know the restrictions, and we also can see that x minus 4 could be easily canceled out. And based on what we did yesterday, when we cancel something out, that gives us a huge hint, and that is we have a whole. So we now know that there is a whole, and the whole is going to have an x value of 4. Okay. Again, there will be a whole because 4 still cannot be part of the function. But if we reduce it, it would appear as 7x over x plus 3. And for the stuff that's remaining, we can tell that the vertical asymptote is x equals to -3. So let's go ahead, draw our vertical asymptote right here. Okay. And then your horizontal asymptote, it's y equals to 7. Okay. All right. So to find out where the whole is, we know the x value for the whole, which is 4. So we can just put the 4 into the x. So for the whole, we will have 7 times 4 over 4 plus 3, which is 28 over 7. And that gives us 4. So so we have 4 comma 4 as the whole. Okay, so you would draw an open circle right there, and the graph will approach to this, will go through this hole. Okay. And we will use the reduced, expression to find out our x and y intercept. What do we do to find out the x-intercept? We will set the y equals 0, or the numerator equals 0. So 7x equals 0. So that means we have the x-intercept at the origin. And if that is the case, that would also be your y-intercept as well. Okay. So based on these features, we can now make a graph, at least for the right-hand side of the graph. So we can draw this. All right. And since there's no square of any kind in the denominator, so the graph would go, would be the diagonal quadrant. Okay, so that's how we will finish our first graph. And if you want to find out what is f of 2, you would just go ahead and substitute 2 into x. So you have 14 over 5. That is your f of 2. And for f of -1, so you substitute -1 into x. So you have -7 over 2 as your f of -1. Okay. So quick few things to make sure that whenever you see some terms being canceled out, then then it's gonna signal that there is a whole, and for the factor that's being canceled out, you still know the restrictions. Well, then that x value is the x value of the whole. Okay, so we'll do a few more practices, and then we can tell. Let's go ahead and write down the domain. Now, this is how I do the domain, how I write down the domain. I basically would just scan from the left to the right for the domain. So I'm thinking about what x value could be what x values could be the domain. Now, if you know the restrictions already, that would also help. So if you scan from the left to the right, so you go from the left to the right, and you will have a stoppage right here at -3. So we'll say from -infinity to -3. And then we have a stop. And then from -3 all the way to, and we keep going, -3, going to the right, and then we stop again at 4. There's no x value of 4. And then we go from 4 all the way to the right. So we have these 3 segments, 3 intervals of our domain. From -infinity, stop right here at -3. And then from -3, keep going, stop right here. There's no x value for 4. And then from 4, we go all the way to the right. And then for the range, so the way you look at it is from the bottom, and you move up. So we go from -infinity, okay, and you think about keep going up, and where does it stop? And we say, well, it first stops at 4. And then after it stops at 4 right here, it keeps going and it stops again at 7. And then going past 7, it would just keep going all the way to the top. So we say it is 7 to infinity. Now, so what I want you to do is this. Do not make life more difficult. You draw your graph. Please extract the domain and range based on your graph. Okay? Make sure you know what it means to write down the domain and range, and just use the graph to write your domain and range. So if you draw properly, then you will be in a good shape. All right. Any question for number 1? All right, number 2. So let's go ahead and take a look at number 2. Something that we can tell straight away is that what is the horizontal asymptote for this case? Y equals to 1, because they have the same degree. So so we just do the ratio, x squared over x squared, which is 1. And then we are going to factor the numerator and denominator. They look very easy to factor. So x plus 4, x minus 2, x plus 3, x minus 2. So again, let's go ahead, write down the restrictions. And we say x cannot be -3, and x cannot be 2, because they would both make the denominator 0, and they will be undefined. And what you can also see is that the x minus 2 would get canceled out, which gives you a reduced expression of x plus 4 over x plus 3. And from here, you can tell a few things already. You can tell that the vertical asymptote is x equals to -3. And there's a hole. The hole is 2 comma. Well, you need to find out where the hole is. So since you know the x value of the hole, you put it into the equation. So you have 6/5. So 2 comma 6/5. So just somewhere right there, there's a little hole. Vertical asymptote at x equals to -3. Horizontal asymptote at y equals to 1. Oops, sorry. Y equals to 1. All right. And then x-intercept is to set the numerator equal to 0. So you set the numerator equal to 0. So you have -4. -4 comma 0. Okay, so -4 comma 0 right here. Okay, and then the y-intercept is to put 0 into x. So what you would get is 4/3. So somewhere right there, 4/3. And based on these features, I believe you can make a graph already. Now, the way you make the graphs, or these two portions of the graph, is this. In order to pass through these points, this is the only choice for the graphs. If you plot it on the other half or the other quadrant, then it will be quite impossible to pass through those points. So that's how we know. That's how we know. All right, now we have a little interesting question right here. What is f of 2? Okay, I'm going to put a little star right here. Okay, what's f of 2? F of 2. Now, I'm going to put a star right here. I hope everyone can take a moment and focus on this question. F of 2 is undefined. Yes. Louder? Yes, because we said the whole is at x equals to 2. So now it might be tempting to put a 2 at the reduced equation, but keep in mind that there's a hole. You look at the graph, when you look at x equals to 2, that's where the hole is. There's no value. There is simply no value when x is 2 because it's part of the restriction. Okay? So be very sensitive of what x could be and what x could not be. So the domain in this case, okay, again, you would go from the left to the right. So you go from the left. So you go from -∞, you move all the way, and you stop at the vertical asymptote, which is -3. And then you go from -3, and you keep moving to the right, and you stop at the hole, which is at 2. And then after 2, you keep going, and you can move freely to the right without any kind of stoppage. So we go from 2 to infinity. Okay. And for the range, we do the same thing. We scan from the bottom to the top. We say the y could go from the bottom all the way to the horizontal asymptote. -∞ to all the way to 1. And then union from union here. And then from 1 to where the hole is. So it's a little small, tiny interval. And then from the hole, the y value of the hole, all the way to the top, to infinity. Okay, so again, use the graph, use what's there to tell yourself. Okay. Now, want to yeah, let's go ahead and try this one. Number 3. So number 3, we can tell the restrictions already. So the restriction is, or are, x cannot be -2 or 1. Okay, and I will highlight something right here that there's a little square right here. We talked about this square yesterday, about the multiplicity. And since it is in the denominator, so we're going to do something. Okay, going to be aware of something as we put our asymptotes. Now, the x plus 2 is being canceled out, so we know one thing already, which is the whole. It's going to have the x value of -2. Now, if we reduce it, so you have 1 over x minus 1 parentheses square. You can tell the vertical asymptote is x equals to 1. And where is the whole? The whole, it's going to be at 1 over -2 minus 1 square, which is 1 over -3 square, and then it's 1 over 9. So at -2, it's 1 over 9. And what is the horizontal asymptote in this case? Y equals to 0. Okay. So so just go ahead and draw the horizontal asymptote at 0. Okay. Wait, hold on. I did the wrong. Oops. Hold on. I drew the wrong thing. Should be right here. Positive 1/9, not negative 1/9. Okay. The whole should be right here, above the x-axis. All right. Now let's go ahead and do our x and y intercepts. Could we have any? Do we have any x-intercept here? Well, we need to set the numerator equal to 0, but the numerator is 1, and 1 can never be 0, so we don't have an x-intercept. And when we have the y-intercept, we put 0 into x. So you have 0, comma 1. Okay. So with this, you can actually plot the left-hand side of the graph. And because of this square next to the x minus 1 in the denominator, then you can go ahead and draw the other side of the graph. Okay. So that will be the graph. And if you want to find out f of 10, f of -10, so you have -10 minus 1 square, which is 1 over 121. Okay. Now I'm going to let you try to write the domain out. Okay. Using the graph that we have drawn here. Try yourself. Try this yourself. What is the domain? So what's the domain here? The domain is from -infinity to -2. We can stop right there. And then from -2 to 1 because of the vertical asymptote. And then from 1 all the way to infinity. Okay, again, you just scan from left to right. That's a domain. And where do you stop? And whenever you stop, you write it down. And for the range, well, there's nothing over here. There's nothing over here, so you do not start at negative infinity. You got nothing here. So you will start at the horizontal asymptote. So from the horizontal asymptote, it moves up, but it quickly stops because, well, actually, now, so this is a little bit challenging here. There's a hole right here. But as you can see on the right-hand side of the graph, the right-hand side value actually covers that 1/9 value, because the right-hand side of the graph would keep going towards the 0. So your range is actually just 0, infinity, from 0 to infinity. Okay. So you may want to write down the reasoning. Okay. The right side of the graph has y equals to 1/9. Okay. So while the left-hand side of the graph does not have the 1/9, the right-hand side of the graph has the 1/9. So that's why we don't need to stop at 1/9.